In the intro, I talked about how streams have shaped the landscape through erosion and deposition. The image on this slide is showing, I think it's Chattanooga, Tennessee, but not positive, the erosion that the stream has done to that whole wall of limestone. The velocity of the stream relates directly to the erosive power of the stream. The higher the velocity, the more erosive the stream is going to be. Streams convert potential energy to kinetic energy. For example, fast water flow. It's going to lift and move more solids the faster that water flows. So it's going to erode more and transport more sediment. The stream is going to break, abrade, and dissolve materials. Generally, we're talking about earth materials, right? Maybe there's an old car in the stream, but the stream is going to break up the bedrock, dissolve the bedrock, abrade the bedrock, but also any clasts that are incorporated in the bed load. It scours and picks up sediment and moves it along, breaks it and lifts it. It breaks chunks of the rock off of the channel, so breaks the bedrock off of the outcrop. The term that we use for the sandblasting activity that happens when the water entrains like sand and it erodes because of pieces of sand hit other pieces of rocks is called abrasion. The bedrock surfaces can become polished and smooth. One neat thing you'll see sometimes in fast-flowing water are potholes. There's one here in this bottom image. And that happens when a piece of gravel gets into like a little divot in the bedrock and then just swirls and swirls and swirls and swirls in that hole over hundreds of years and makes a little pothole. So sediment is moved by the stream, and there's two different terms, alluvium and fluvium or fluvial sediment. Alluvium is a general term for sediment deposited by moving water. Fluvial sediment is sediment in or deposited by a river system. On the left, there's a meandering stream with point bars on the inside of the meanders. Those would be fluvial sediments. On the right is an alluvial fan. So this is where water has come out of this steep mountain up to the right and channelized, bringing lots of sediment down off of this high relief slope. And when it hits the bottom of the slope, the velocity of the stream goes to zero, essentially, and all of that sediment gets deposited in this alluvial fan. This is a huge alluvial fan. There's a road coming across the toe of the alluvial fan. Sediment in the stream can be classified as either dissolved load, suspended load, or the bed load. The dissolved load would be ions, so those charged particles that are moving along in the water. The suspended load is going to be a finer grained sediment like a clay that's entrained up in the water column and flowing along. If you look down into a stream, it looks muddy. Those are usually clay fragments, and that's the suspended load. The bed load is going to move along the channel floor. Sometimes it can bounce along. We term that saltation. So the bed load can be rolling or bouncing. The bouncing is the saltation. There are terms we use to describe the size and the volume of sediment, and that's the competency and the capacity. The competency means the size of the clast. The capacity is the volume of the clast. And the amount of those depends on the velocity of the water. So we'll speak of it in terms of discharge. If there's a high discharge, a lot of volume of water coming, there's going to be large cobbles and boulders that can move. This can be in a high gradient stream like in the image here, or in a flood situation, we would get boulders and larger cobbles to move if there's more water in a flood. Lower discharge means there's not going to be big class moving. Okay, so that's moving the sediment along. The sediment eventually is going to get deposited somewhere. Deposition is going to occur when the velocity decreases. So the competency and the capacity are going to decrease with decreasing velocity. The sediment size is going to be directly related to that velocity. So as the velocity slows, the first sediment that's going to fall out or stop moving or get deposited is going to be boulders, and then gravels, and then sand, and then silt. Different size sediments are going to be in different parts of the stream. So those gravels and boulders are going to be in the stream channel. Sand is usually going to be like on a point bar. Muds are deposited in slow eddies along the stream channel, but also mud, because it's a fine-grained like clay size, is going to be carried out and deposited on the floodplain when the water leaves the channel during a flood. So floodplains usually have pretty muddy sediments in the stream channel. The sands are usually going to be in the point bars, and then the boulders and gravels would be, around the thaw wedge where the water's really moving.